Very good morning. Welcome to lecture 41, Classification and Regression Tree, a case study. This is under module 8, Predictive Safety and Risk Analytics. So again, we will describe a case study here. It's a real case study, data collected from a real plant. Here we will basically first give you the case description. Then we will show you the data and variables. Then we show you the cart development, and then we will show you basically related to the cart, that feed measures, and also we will show you the predictor variables, importance of predictor variable, Okay. So I hope that I will be able to finish it by 20 minutes of time, because the basic part is known to you. Already I have discussed in previous class that what is the concept behind cart, and you have seen basically cart as a classification tree, binary splitting it does, and it consider the best split. There are three growing issue, growth of the tree, and then the stopping and the prediction. Those things are known to you now. So I want to explain first the case. This case is a real case, so it is not synthetic or a mixture of synthetic and real data. It's a real case. Here study was conducted in underground coal mines. Mine operators in a mine operates 3 shifts a day and 6 days per week. The manpower is around 920, and actually it was a old data set, but it was done during that time, and with average daily production of 100 metric tons. When an accident injury takes place, a report describing the event is prepared by the mining officials and is being maintained in a company records. For each of the injury incident, the severity of actual and potential injury, date and time of the incident. So severity and actual and potential injury, date and time of the incident, name and job designation injured are recorded. Activity carried out of the time of injury, which body parts injured, what is the medium of injury, these things are recorded. Okay. So you all know that mining is a very hazardous occupation, and this incident recording scheme in mines are very much I can say robust in nature, because you have to have such recording scheme, and it is being practiced also. It's being in India, it is being practiced long ago, because this incident or this accident records, if you analyze, so ultimately what will happen, you get a lot of insights, so that the repeat accidents can be avoided. And with this notion in mind, this kind of record keeping have been practiced in Indian mines. And you can understand that the study we have done long back, but even today this kind of data and the relevance of the study is not ignored, because in the sense, yes, it is there, still there. It is one of the PhD work, one part of the PhD work of one of my student, that the source is given, that Khanjodi et al. 2010, and this paper was published in one of the leading safety and ergonomics journal called Applied Ergonomics. Okay. So we have used little more data in this case. What we have published there, that time we are having little less data, but when finally at the end of the study period we got some more data, so that's why you get, from the number of data capture point of view, there will be certain difference. But nonetheless, the information what is presented in that paper and what we are getting from this analysis, these are more or less same. Mostly, basically, I can tell you, in that paper or in our study, that time when this was analytics was, or some kind of predictive analytics like CART classification tree, these were not that popular. So we have adopted a different approach there. We basically developed there the performance of the safety measures or the risk control systems in terms of reducing the potential severity to some kind of lower level actual injury severity. Basically, we tried to model injury severity. The interesting part of this work is, to me it's a fantastic work. Actually, what happened, all the 224 records that were manually read by us, and then we found out that what are the basic causes of those accidents, and we created 4 level of interfaces, or other way I say the causes. Some cases P mean person as a cause, means where person is responsible, the victim is responsible. Second one is system as a cause, that means either co-workers or the system related things were problematic. Third one is injury IP, that basically interface, and where person, and IAS basically that interface where system is basically more responsible. Okay. So this is one derived variable which are not there in the data set. Our concept was that if any accident takes place, person system person interaction, and that those things basically very, very important, and that is what we captured here. Okay. Now, now in addition to this, when actually that the mine particularly has a very interesting system, they basically, when they record the severity, injury severity, that what actual severity, another one is what could have happened, that is basically potential severity. So we adopted the approach that if potential severity is fatality and actually there is some kind of reportable injury takes place, then definitely there is some system effective system which reduces this that severity. An interesting part is that we observe that most of the cases a higher order potential situation is basically actually realized in a lower level. That is the interesting part. To further strengthen the model, we found out that not only that injury potential, which is basically the risk level at that time where the accident actually taken place, not only that, we basically understand that the job designation means which occupation, is it a driller, loader, roof bolter, what kind of occupation it is. Second, what activity the person was doing. And then third, what medium, we'll explain again the medium of injury, means what is the hazard level there, and then which body part is affected. For example, in underground mines, from roof chunk of a piece of roof maybe can fall, but if it falls on toe, that will be one kind of severity, but if it fall on head, that will be another kind of severity. So that's why which body part is exposed to that hazard, that is also very, very important. So all those things keep putting together, we developed a model which we say injury severity model. Injury severity model. In the work Khanjode et al. 2010, our basic purpose was how the severity can be explained with the help of job designation, activity, medium of injury, body parts injured, and injury potential. We have used the erudite analysis, but here we are using classification tree, and this classification tree is a new one definitely. And I am happy to tell you that this study was highly praised by the concerned that mine personnel. Okay, so now let us discuss further. So what are the objectives in this study? I talked about objectives in the paper. Now for this case study point of view, what I am presenting to you, the objective is predict injury severity categories, and it is also intended to understand the relative importance of the factors. Basically prediction as well as understanding which factor is influencing the most. In the paper, our purpose was how the injury severity at a particular level, a potential level to realized one, but here the purpose is we want to predict based on the potential, based on all the other predictor variables. Okay. And I told you already the data captured and the number of observation I already told you. And now severity, risk level, job designation, medium of injury hazard, and cause attributes. Now the risk level, basically what I am saying, that starting from injury potential, the potential one is risk level. We have denoted, this is the only difference we made in this variable explanation, because actually what happened, potential one means that was the risk. When it actually realized the risk may be low, so that's also possible. Now let us see that the data. Now the data injury severity, you see first aid, minor near miss. Interesting part, this is the interesting part when you compare with this. So actual or potential severity from the was this, but when actually it happened, it is much lower level. Then why potential one is reduced? Obviously that means there are some reasons, and that reasons for the I can say that we should be happy for that, because it is reduced. Need not be that it will always be reduced. If you do not do good work, it may increase also. Means actual level is maybe minor, but actual level potential level may be minor, but actually it becomes serious. That also may happen. Okay, but here this is basically the other variables. So you can understand that these are all categorical variables. Severity, three categories. Job designation, 1, 2, 3, 4, 5, 6 categories. Risk level, 3 categories. Activity, maintenance activity, operation, travel related activities. body parts 1, 2, 3, 4, so many categories, hazard, ground related hazard, machinery related, material related, other hazards, and cause attributes. These many things are there. So as all are basically categorical in nature, I think this CART kind of classification tree is a better alternative for modeling of the modeling of the data. Okay. So with this background, now I will show you that what is the result. So result is that I can tell you one thing here, that although we were having 224 observations, but we bootstrap to 500 observations. Here data points means basically observations. So the primary purpose is to increase the number to suit to the machine learning model, for that CART model based on machine learning approach. So we created two data set. One is training data set, another one is test data set. So we consider 403, test data 97. So that means almost 300, one fourth consider for test and 3/4 consider for training. This training is used to develop the model, test is used to verify the model whether it is good or bad. So that sense. And right hand side you are not able to visualize properly, but this is basically the output of the CART algorithm classification tree. We followed binary branching. Okay. So with this, what I will do now, maybe by another few minutes, I will just explain first with little better visibility the CART, that in the tree, and then I will show you the feed measures there. But here you just see from the injury severity point of view, the count and the percentage are giving. Okay, no problem. So the root node, in the root node, actually the class that see that first aid, minor and near miss, the percentage this is given. First aid 299, minor 56 and near miss 48. Total is basically 403. This is node 1, not root node. Actually 500 is the total data. In the root node, when you basically make a class, basically 597, what is given here. So we split the data into two parts, as I told you earlier, 403 and 97. Now using 403 training data, we are now showing you the development here. This is the total development, but it is not visible. So I am going to next. Here we consider 403 training data set, that is the first node, root node, and here first aid, minor, near miss, this is there. Using impurity measure, you can find out what is the impurity here, either entropy, Gini, or misclassification error, that you can use and find out the impurity measure. Then what happened, as you have many, you can see that you have many variables starting from the job designation, risk, activity, so many variables. So you can what you do, you can now find out the best split and go for splitting. Now first split, what we got here, that body parts. Then after that you find out that here in this node 2 there are near miss is 0, other 2. So that means little more homogeneity is achieved. Here 3 groups are there, here only 2. Here you see first aid and other things, these 2 are 0, only near miss is there. Okay. Then when you go for again the second level, then the second variable is coming risk level. Then when you split it into two parts, actually here what happened, you see here mode that means first aid, and here it is minor. Okay, so then first aid basically actually first aid here is 49 and minor is 31, here 250 and 25. And now then the next category is cause, that cause attribute which basically contribute, and in this manner it continue. And finally what happened after cause, again you see that again body part is coming. So it is the interesting part. So there are, I think, few more variables which are not taking part in this particular development, because when you first split, the body part comes into picture. In the second split what happened, that risk level come into picture. In the third split, causal attribute comes into picture. Then when you are going for the fourth split, again body function comes, and here we stop. Now its stopping criteria, as you see, the way you ask the algorithm, the stopping criteria will be chosen accordingly. Maybe if you use another kind of stopping criteria, or another kind of, maybe if you basically, there are so many categories per variables. So if you reduce the categories by some scientific manner or logical manner, you may get a different tree. Or if you change the stopping criteria, so that means you will get a different tree. It may be more, and a few more variables will take part. So essentially what I want to tell you here is that CART ultimately gives you what are the variables which are taking part in the split, which are the variable not taking part, that also you will know. Why it is not taking part, that also you will be able to know. You have the opportunity to change the splitting condition situation, then more variable will be taken part into the development, and ultimately what will happen. So essentially you are getting a tree, and that tree not only help you in classifying the new observation, but it also gives you rules. From the classification tree you can develop rules also. Okay, so with this I will show you first which are the variables important. And here in CART, actually the importance of variable is created with reference to the most important variable. The most important variable influence is considered to be 100. It is nothing but from the gain point of view, impurity reduction point of view. Body function or body parts, what is the total involvement in reducing the impurity? So that one is the maximum, followed by designation, followed by risk level, followed by causal attribute. And the contribution in terms of impurity reduction by body function is considered to be 100, and then accordingly other contributions are normalized. And that's why 100% if it is contribution by body, 100 is the score, then designation score is 43, risk level score is 19.3, causal attribute score is 6.4, activity, medium of injury, those things have not taken part in this particular classification tree. By doing this, you should not ignore the importance of medium of injury, and I can say also activity, because it may so happen that as you are doing binary splitting, so because of the complexity, it is a non-linear issue nature, and in some of the split what happened, the effect of other variables is segregated in that manner that it never comes into picture. So these are the drawbacks of this kind of binary branching. Okay, so it is better to, maybe you can redo some kind of categorization, recategorization of the categorical variable. Maybe you may reduce the number of categories at the beginning, and then and then you see what is happening, you may get a different kind of results, and that is basically known as model building or insights drawing. You don't require to keep all the categories of a particular attribute all the times. You have to do it in such a manner that it will ultimately help you in generating insights, and that insights will be used for further improvement for the purpose the model is built. Real practical implementation point of view, if you consider for our case, then definitely body parts, obviously it will be, because we are talking about injury severity, it will be a serious issue. If head is hit, then definitely you will find out the severity is higher. So protecting the body parts, that's why it is so important. But again, protecting body parts is not at all easy task. So as a result, you have to maybe have that it is happening that body part is coming into a very big way. It may so happen that some of the time I think maybe if the job can be made automatic, in the sense machine dependent only, so that the exposure can be reduced. Another one, designation category is important, because that means certain designation category they are actually really contributing. All the designation categories are not equally severe in terms of severity of injury point of view. Okay, and these are obvious things. In the sense it will happen. What is the importance then if it is obvious? It is not, by saying obvious, I am not saying that the study is obvious. I am saying basically if the body part will be an important parameter or important variable predictor, that is what is important. Another issue is that the confusion matrix is also prepared, and in the confusion matrix you see that actual and predicted class, and you see that performance is not that good, in the sense overall 63.9% correctness, but from the near miss point of view it is 100% correctly classifying. Minor point of view it is 85.7%, but first aid point of view it is very 53%. So these things may happen, and in real life situation, please understand, in real life situation you will get this kind of results. So you may require to do lot of domain specific or expert based that data pre-processing, derived variable creation, so many things is required. But nevertheless, I am telling you this study is equally important, because it also gives you idea that where to concentrate your effort so that the improvement will be possible in terms of reducing the injury severity in future. So I am sure that this case study helps you understanding the use of CART in real life situation. My request to all of you, why can't you go through the paper what is basically given in the reference, that injury severity assessment for underground coal mine workers, applied ergonomics, and you develop something new out of it, and you just see that how if CART is giving this performance, you may use logistic regression if possible, you may use support vector machine or other kind of machine learning algorithms what we will be discussing in the future classes, or what you might have already learned or you might be learning. And you can, and another issue is that the concept what we discussed here, that can be used in other domain also. So the scope is enormous, so you may take it forward. Thank you for your patience and kind listening to my lecture. Hope you all the best. Thank you.